This is the video for Concept Quiz 24 review. Part A, a highlighter manufacturer claims that its highlighters have a lifespan of 9,000 uses with a standard deviation of 2,100 uses. The distribution is approximately normal. What percentage of highlighters can be used at least 7,300 times? So, if you look at the average lifespan, which is 9,000, and the standard deviation, which is 2,100, and then we're being asked about the percentage that a highlighter can be used at least 7,300 times. We first want to see where on the normal distribution that is. We want to see how many standard deviations away from the mean 7,300 is. So I'm going to find the z-score for 7,300 uses. So it'll be 7,300 minus the average, which is 9,000, divided by 2,100. The z-score formula, in case you need it, is x minus x bar over sigma. X represents the data value that you're being asked about. The x bar represents the average, and the sigma represents the standard deviation. So in this problem, 7,300 is what they're asking about, 9,000 is the average, and 2,100 is the standard deviation. So the z-score, or the number of standard deviations away from the mean, is negative 0.81. You want to always round to 2 decimal places because we're going to use the z-table, which always goes to 2 decimal places. Now, in order to find the percentage of highlighters that can be used at least 7,300 times, you're going to be looking at your z-table on the negative side, and we're going to look at negative 0.81. So that's the second column here. So 0.2090 is the percent. But this table represents the percent that's less than that. Whereas the question, so let me just make a note of that, 0.2090. So 0.2090 is equivalent to 20.9%. That's the percent of highlighters that would be used less than, notice here it's shaded to the left, less than 7,300 times, but it's how many, or what percent of highlighters can be used at least 7,300 times. That would be the same as asking used more than 7,300 times. So in this case, I need to subtract from 100%. So that would actually be 79.1%. All right, on part B, the average cost of a 1966 Ford Mustang is $26,937. Standard deviation is that. And Paul has a Mustang for $13,695. The cost of Paul's Mustang is blank standard deviations above or below the mean. So we're going to use z-score again. His Mustang is $13,695 minus the average Mustang divided by the standard deviation. Minus 26,937 divided by 7,523. So negative 1.76. And this is, well, if we're looking at the above or below, because we got a negative, that means automatically that his Mustang is below the average. So I'm actually going to change this to just 1.76 since I'm already saying that it's below the mean. Okay, on part C, what percent of the normal curve is shaded? So this is the empirical rule. We know that within 1 standard deviation of the mean, there is 68% of the data. So that means this is 34% and this is 34%. We also know that within 2 standard deviations of the mean, we have on both sides here another 13.5% here and another 13.5% here. So within 2 standard deviations of the mean, you have 95% of the data. So the shaded portion here is just 34% plus 34% plus another 13.5%. So 68 plus 13.5 is 81.5%. All right, part D, 2 athletes, Mike and Marissa, are competing for an MVP award. Mike is a quarterback on the football team who scores approximately 6.3 touchdowns a game. The average quarterback scores 3.8 touchdowns, standard deviation of 0.7. Okay, now Marissa is a pitcher on a softball team. She pitches approximately 14 strikeouts. The average pitcher pitches 7 strikeouts with a standard deviation of 1.5. Which athlete deserves the MVP award? So these are 2 totally different sports, but we're going to compare them based on how far away they are from the mean in standard deviations. So we're going to use the idea of z-scores, so number of standard deviations from the mean. So Mike, he scores 6.3 touchdowns per game. The average is 3.8, and the standard deviation for that is 0.7. But Marissa, her z-score is based on her 14 strikeouts per game. The average pitcher pitches 7 strikeouts per game, and the standard deviation is 1.5. So we're just going to see who is farther away as far as number of standard deviations from the mean. So 6.3 minus 3.8 divided by 0.7. This person, Mike, is 3.6 standard deviations away. And then Marissa is 7 divided by 1.5. She's 4.7 standard deviations away. So Marissa deserves the MVP award because she is farther away, farther above average according to her z-score. Alright, so this last question here, people in the US watch an average of 311 minutes of TV per day. Standard deviation is 66 minutes. A randomly selected woman is found to be in the 46th percentile of television watchers. That would be 0.46. So you're given the percentage. How many minutes of TV does she watch? So we're going to work backwards on our z table here. 46%, we're going to look for that in our z table. So 0.46, and we're going to get as close as we can to 46%. So it looks like right here, 0.4602. We're going to work backwards to the z-score of negative 0.1. So make a note of the z-score. So we knew the percent, we're figuring out the z-score. Now that you know the z-score, you can answer the question of how many minutes of TV does she watch. So negative 0.1 equals x is how many minutes of TV she watches, minus the average person, which is the 311, divided by the standard deviation, which is 66. So if you solve that equation, multiply by 66 by negative 0.1, and then we would have to add the 311. So that's 304.4 minutes. Alright, draw a dotted line on the curve to represent the number of minutes at which 68% of people watch less TV and 32% watch more TV than the woman in part 1. So we want to look at the one which is less, so 68% of people watch less. Look up 68% in your z table. Get as close as you can to it. Right there, the z-score is 0.47. And then you would do the same thing you did on part 1 to find the number of minutes of TV that person watches.